in this video, I will explain you how you can invoke Objective-C code from Swift code in a Swift project. I will present you the way we proceed by means of example. The idea is to show you how you can create objects written in Objective-C from the Swift side. So we are inside a Swift project and we will invoke Objective-C code in a Swift manner. The idea is to complete several operations, init objects written in Objective-C, show various access to attributes, private and private, by means of accessors, etc., etc., and also to show a method invocation. Let's have a look on the way my application works, and you will see that it's very simple. It just displays two labels, and in fact, what you at this stage have to trust me, but the value of these labels is provided by Objective-C code, not by Swift code, but we will see that very soon. The architecture of the application is the following. So you have, as usual, your app delegate and your ViewController. Here you will discover that there is a mapping between Swift and Objective-C. So this mapping allows to tell Xcode that there are some Objective-C headers, typically myclass.h, that are imported, and then there will be a binding done, an explicit liaison provided, done by Xcode. And of course, aside myclass.h, you have myclass.m, that is the implementation of the Objective-C class. Let's see how it works in Xcode when you insert a new file that is not in the native language of the project. So here I am in a project that declares the language, the main language is Swift, and I will add a file and I will specify that this file is not a Swift file, but an Objective-C file. Okay? So it's a Coco Touch class, for example. I'm doing next, and here I say, no, it's an Objective-C class. I call it my class. Okay, so you are used to that. But here it proposes you to create a bridging header. In fact, the first time it proposes it to you, you really have to do it. And then you see that you have now two extra files, the .h and the .m, so the header and the implementation of the Objective-C class, and then you have this header file that will allow you to perform a bridge between Swift and Objective-C. Just a look on the bridge file. Of course, you just insert here the Objective-C class that you directly invoke from Swift. For the classes that are invoked by means of an intermediary class in Objective-C, no troubles, okay? It's not necessary to put it there because it's not invoked from Swift code. So, in fact, you can directly and easily refer to the classes in Objective-C you want to be visible from Swift. Let's have a look at my class. So my class is written in Objective-C, so here I have the .h file. Just a word about this directive that appeared recently. It's a directive that tells that the init will not return nil. If you drop this directive, then from Swift you will have to invoke init as if it was an init question mark. So it may return nil. Okay? And if you let this directive, Swift will consider that nil can never be returned by init. So aside that, this is very classical. You import what you need here. Typically here I'm using UI color, so I need to import UI kit. But once again, this is very classical. I have my class with two properties, my value and my color, and two methods, the constructor, init with value and color, and another accessor that is compute. Let's have a look on the myClass.m. So this is the implementation. So as usual, you have the import of the header file and you have the implementation of the constructor here and of the compute method. So everything is totally normal. It's very simple, very classical code. Let's now have a look on the ViewController. So we switch from the Objective-C side to the Swift side. And so the ViewController is written in Swift. And here everything will be put in the ViewDidLoad method. So you see that I'm creating elements, graphical elements, so initializing the two labels. I'm setting directly their position because I'm not dealing with orientation on this very simple application. And then I am creating two objects of type myClass. So you see that here, okay, this is the first one, and I create it with a value which is I am the Objective-C part and a color which is red. And then I use for my first label the information I can fetch from that object one. And I have another way to create a myClass object differently. So I'm creating it without any parameter, with a default in it, and I'm accessing to the attributes. I can't do that because these attributes have been declared in the .h part, not in the .m part, so they are public, they are visible. So you see that from the Swift side, I do not see any difference between the use of a Swift program object or an Objective-C programmed object. And then I do what's necessary to add the two labels on my main view. That's all. So it's really easy. You just have to get the Objective-C code you want to reuse. You just have to make this binding, and then the bridge is done between Swift and Objective-C, and Swift can invoke Objective-C. So it's useful until probably Objective-C is being ported to Swift, and then you don't need these classes anymore. One more thing. What about the reverse operation? So we dealt with invoking Objective-C from Swift. Now we might like invoke Swift from Objective-C. Of course, this operation is of less interest. Why? Because the trend is to change Objective-C code to Swift, not the reverse. So it means that a priori, when you create a new project, you create it in Swift, and then you might have some remaining libraries you want to invoke that are still written in Objective-C. But of course, as you can imagine, the other way is absolutely possible. There is a main difference that the bridge from Swift to Objective-C is automatic. I will explain you how you can make it automatic. Of course, in a Swift project you cannot deactivate Arc, while you can do in an Objective-C project, but the Arc will still be there for the Swift part. And in fact, the bridge from Swift to Objective-C is automatic. But you may need a bridge to expose other Objective-C classes to Swift. Because let's imagine you are in an Objective-C project and then you just have a single class that is written in Swift. So you may, from your Objective-C code, invoke Swift, but the Swift may use other parts that are written in Objective-C. And so you still have a bridge, but the bridge is not intended to export Swift to Objective-C, but to let the Swift part of the project have access to the Objective-C part of the project. Okay? And I told you that the exposure of Swift entities is automatic. It's automatic only if you add the directive at OBGC, sorry. Okay? And you probably noticed that when we were doing some at target or anytime we had the creation of a selector that was provided somewhere, we had to have the corresponding method preceded by @objc. And this is the way you can expose a method, and you can have this directive also in front of a class. And then the whole class will be exported and exposed to the Objective-C part of the project. Let's just show you a very small example. So here is the implementation of my class, or an implementation of my class, okay? It's inheriting from NS object, it's export an attribute and a method, and since I have this directive here, the whole class is visible from the Objective-C part of the project. So, from Objective-C, it works as usual, as if the code was written in Objective-C. So, it's the idea. You are writing Swift code and you invoke a class either in Swift or in Objective-C without any idea of how it is implemented. And of course, you expect a similar thing from the other way. So if you are in Objective-C, you can invoke any class the same way, even if it's not written in Objective-C. Thank you for your attention. See you later.